Hello, welcome to the 2023 CNIT Capstone presentations. Our first presentation is SmartFusion, a 5G edge computing and machine learning testbed for secure manufacturing. I'm Christina Kimball, I'm the project manager.
I'm Tyler Starsfitch, I'm the 5G network engineer.
I'm Robert Smith, and I'm the edge computing engineer.
I'm Nicholas Langenfeld, and I was the lead AI and machine learning engineer.
I'm Andrew Williams. I'm our AI chatbot engineer.
My name is Ian Berner, and I was in charge of network security and 5G security research.
And I am Nolan Struble, and I was the chief cloud engineer for this project. We're going to begin a presentation for you folks tonight, or this afternoon, I suppose, by talking about what smart manufacturing is and a little bit about the project. Then we'll move on to a recap of the previous group's work on this project. As Holly discussed, we are actually the third generation of students working. Then we'll talk about our focus for this project and our topology before jumping into how those technologies were implemented and our demos and use cases. Finally, we will wrap up by talking about costs, roadblocks, and lessons learned. So let's begin. This project was first conceived of 3 years ago during the height of the COVID pandemic. Businesses everywhere were struggling, and the Department of Defense, who sponsored this project, wanted one question answered. How do we bring manufacturing back to the United States? Well, the answer is that we do something the United States has typically done pretty well. We innovate. Smart manufacturing is about using cutting-edge technologies in a traditional manufacturing environment. Technologies like artificial intelligence, machine learning, environmental monitoring, to improve things like efficiency, cost, safety, and security.
I'd like to take you all back in time for a moment to 2021, where the first iteration of this project began, and they laid the foundation for what would continue to be our project today. We start off with the manufacturing test bed that you can see in the bottom right-hand corner, where we used Meraki devices to connect to the cloud. They also implemented a long-range wide area network sensor and started implementing security measures for those cloud services. Now in 2022, they took it even a step further by trying to implement the machine learning aspect of this project and implementing a zero trust principle so that they could continue to keep this information private. On the right-hand side, you can see where the testbed connects to our Meraki wireless access point over Wi-Fi 6 and is used duo multi-factor authentication for user access as it is VPN'd into the cloud to access AWS services. And now to our present day.
This is our present day topology. We've added in our 5G wireless network, which hooks up through Amazon Wavelength up to the cloud. And then we've added a variety of Raspberry Pis for cameras for our AR person detection model, so that we can actually add some machine learning aspects to the project. They're all interconnected with our Wi-Fi 6 wireless access point for all the various sensors on the topology. And next, I would like to show you or talk to you about our focuses: machine learning, AI chatbot integration, 5G connectivity, environmental monitoring dashboards, and security.
One of the main focuses of this project was machine learning and AI. Using machine learning, we can create models that can identify patterns and learn from data that we input into the models. This allows us to create systems that can complete complex tasks in a manufacturing environment that would normally require a human worker. And this can overall improve production efficiency and improve worker safety by taking humans out of dangerous working situations. We also implemented an AI chatbot into our environment, and this consolidates all of the information from across the entire organization into an easy-to-use platform that you can interact using natural language, which allows non-technical users to get technical information and can overall save the organization time, and which ultimately saves money. Now I will hand it off to Tyler to talk about our 5G.
So you may be asking yourself, why 5G? Well, 5G brings many new technologies that are available to us for our smart manufacturing platform that wasn't previously possible over past cellular technologies, one of which is higher speeds. This allows our smart manufacturing platform sensors to upload data at a higher rate or have more sensors operate and upload data to the cloud at the same time. Another benefit of 5G is lower latency. This allows our sensors on our smart manufacturing platform to connect to the cloud at a lot faster rates than what was previously possible with past cellular technologies. Another benefit of 5G is edge computing. This is where the cloud is placed closer to the edge, and I'll talk more about this in a second. Another benefit of 5G is private networks. This is where the 5G network is 100% placed on-premise within your company's data center for more security, rather than relying on public 5G network, Verizon, AT&T, or T-Mobile. A final benefit of 5G is power consumption. 5G modems have become more power efficient, which allow our sensors on our smart manufacturing platform to operate at a longer life on battery, or if connected to mains power, to have a lower TCO output over time. To our right, we have a simple edge computing diagram that we used called AWS Wavelength, which we implemented with our 5G Verizon SIM card. On the right-hand side, we have our Verizon public 5G service, as you can see with the towers and the mobile phones. And then we use our AWS Wavelength zone as our edge computing technology in the middle there. And on the very left-hand side, we have our normal EC2 instance on the East Coast. With edge computing, as you can see, since it is placed closer to the edge of the cellular network, this allows us to have a much higher data rate of throughput and much more latency than what we can get out of our normal EC2 instance, since it does not have to traverse across the normal internet to our AWS region located on the East Coast, but rather placed in a Verizon data center in downtown Minneapolis. Now I'll hand it off to Christina.
Another technology we worked on implementing was environmental dashboard. So environmental monitoring is a way for companies to observe and react to changing conditions on site. This data is collected via sensors. What kind of data that's collected depends on what kind of sensor the company has and what kind of data they would like to analyze.
Now, as much as I'd like to, I can't sit here and tell you that there's zero risk with implementing these new technologies. 5G sounds amazing. It gives you the faster data rates that you want, and you should just employ it right now. But the fact of the matter is that as with any new technology, there's some risk involved. Some of these risks include the virtualization aspect of the 5G technology. As we traverse from our on-premise data center into the cloud, there is always a concern with virtualization-aware malware, which identifies the specific use case and is able to attack the network and is a detriment to any company. Another new area that hasn't been seen before is signal interference. As the band that expands to use 5G from the lower to the mid and now even to the 12 gigahertz high band frequencies, there is a large chance of terrestrial and non-terrestrial in the form of satellite communication interference with traditional 5G or mobile networks. Another aspect which we've tried to employ here is the IoT security, which many of us know that IoT devices aren't in and of themselves very secure. They're meant to be very small and transfer data in small packets to where they need to go and don't have built-in security with them. But the benefit of 5G is a lot of these issues are mitigated through these specific technologies: authentication, encryption, and virtualization. Now I'll start from the bottom because I just said that virtualization may have been a hindrance, but in fact, the virtualization nature of 5G is also a lot more secure than operating in a traditional cloud environment where you would use specific operating systems and containers to run your services. This can benefit and also add a layer of multiple locations by segregating out where the information is brought in and where it is processed. Back to the top, the authentication aspect ensures that each device and service proves who they are and that they need and have access to the resources that they require. And also using 5G, all of the data is encrypted, so in case any of that information is compromised or intercepted, it is deemed completely useless to the attacker. The way we implemented these technologies and how you could as well is through our Amazon Wavelength. Now this serves as our encrypted endpoint for our 5G cellular network that integrates and routes all traffic from the mobile network into the cloud-based core network. This provides you with that security and fast data rate all the way from end to end. And able to deploy multiple and massive amounts of IoT devices is crucial in these manufacturing environments. Being able to trust that these devices are reliable and secure is very important. And by using 5G, we're able to encrypt and authenticate all of these devices on a scale by segmenting them into their own individual network slices with predetermined security and resource protocols and features. Now we're going to get into our business use cases of how we implemented these technologies. First, we're going to start off with the 5G and edge computing for time-sensitive applications by testing the data rates and the limits of 5G connections. We're going to then transition to the automated quality inspection, where we used AI and machine learning to detect faulty equipment in our manufacturing test bed. Then we will go into a people detection model by using cameras and machine learning to detect people in unsafe environments, as well as the AI chatbot for increased productivity and access to information, and finish off with the environmental monitoring dashboard.
So to present our first use case, we wanted to look into the aspects of 5G and see exactly what benefits it can provide. So the first test we like to do was to compare 4G and 5G network speeds. So as you can see here, 5G, it operates at different frequencies, but basically the higher the frequency, the faster the network. And as you can see on the chart there, we can see anywhere between a 17 and 57% network speed increase. If we go to our edge computing service, this is more of a proof for edge computing's low latency requirements and extremely fast speeds. So as we can see, when it comes to comparing a 4G, you can use wavelength with a 4G network as well as a 5G low frequency. However, those results are very negligible. They're very interchangeable with each other. It's when we get into the mid frequency and high frequency values of 5G that it really starts to take off. So for the mid frequency, we're seeing an increase of about 1,000%. That's not a typo. High frequency is also seeing a 1,900% increase there. It's really amazing to see what edge computing can do to meet those lower latency requirements.
Our next use case is using machine learning to automate the quality inspection process. Quality control is one of the most important aspects of any manufacturing environment, and this is traditionally done by human workers manually inspecting a small sample of parts that come off the line. But with machine learning, we are able to create a system that can inspect virtually every single part that is produced with greater efficiency and greater accuracy than a human worker. In order to do this, we used Amazon's Lookout for Vision service, which is a fully managed machine learning service that is specifically tailored for creating machine learning models for quality inspection. We then deploy that model using the Greengrass service to our Raspberry Pi, which continuously takes images of our factory and makes predictions on if a defective part is detected or not. That data is then sent back into the cloud where it is processed further, and automated notifications are sent out to the people on the list if there's a defective part detected. And now we can take a look at this in action.
Here I am connected to the device that is going to be running our quality inspection model. I start the model running by executing this command, and we can verify that the model is running by the success message that is shown in the output. We go back into the AWS console, we can see the live data that is being sent from this model. All of these predictions are false, which is to be expected as there are no parts running through the factory. If we order a piece from the factory by executing the test function, we can see that the factory begins preparing this part for processing. The part will go through various steps in the process that simulate a manufacturing environment, and when it gets to the end, it will have its picture taken, which will then be fed into the quality inspection model. As the part is deposited onto the turntable, it finishes its processing, and then it spins underneath the camera, which is that white arm, and a picture will be taken of it. If we watch on the right-hand side of the screen, we can see a true go through, which means that the camera detected a defect in that part. An email is automatically generated because of that defect, and if we click into that email, we can see that the image is included for manual verification along with a confidence score of about 99%, which is exactly what it should be for this scenario.
Another use case we wanted to explore with machine learning was using machine learning as a safety mechanism. Now, safety is a priority in any manufacturing environment because a safe factory is a productive one. Having high safety means you save money on workers' comp claims, you save money on damaged equipment, and so on. So what we did was build a model specifically designed to detect people in hazardous areas. Traditional safety mechanisms have a lot of limitations. You can put motion sensors in place, but moving pieces in a factory could trip those motion sensors. You can have cameras in place, but those cameras need to be monitored by people, and a lapse in attention by whoever is monitoring those cameras could spell disaster. But by eliminating the human element with a machine learning model, we can create a more efficient, more reliable safety system that detects people in areas that could be hazardous. The workflow for building this model was very similar to what Nicholas just described for our quality detection model, so I'm not going to bore you with the details. Instead, let's just jump right into a demonstration.
Let's take a look at our object detection model in action. We're going to run this Python script on the side. This is going to start our actual live feed from the camera and start bouncing images against the endpoint in AWS. We can see where our security camera is mounted right here facing a hazardous area, and this is our person who's going to wander in. So we're just going to place him down right in the middle of our hazardous area, and we see our camera, our model, pick up on it almost immediately. Now, normally you would probably put down some sort of critical shutdown thing in place, but instead we're just sending an email notification. Now, if we look at this email notification, what we're going to see is a image taken from the security camera that it hit on with the person, a bounding box pointing them out, as well as a sort of generic alert message.
With the almost overnight success of ChatGPT, we thought it would be interesting to integrate it within our factory to provide accelerated assistance to factory workers. But unlike ChatGPT, we wanted our bot to be specialized, only answering questions to specific data within our network. We were then able to create a specialized index that roped in all of our sensor data that we wanted to add, along with our person detection model, and we created a bot that you could easily ask any question you wanted to regarding the factory. And next, I'd like to show you a demonstration. This is a demonstration of our AI chatbot. You can ask it any question you want. If you don't know what to ask it, you can ask it a question about what questions you can ask. It'll tell you. You can ask it a variety of questions about stock and ID numbers associated with individual items. It'll hand you that information. We also integrated this with our person detection model, and it will give you information related to that.
So the first case for environmental monitoring is environmental impact. Nowadays, more companies are looking at how their manufacturing plants are affecting the communities around them. So they're able to use sensors to collect air, water, and soil quality data so that they're able to look at and make changes. The next use case is validating regulations. There are many industries where they have to follow specific regulations in order to sell the product they've manufactured, such as the pharmaceutical industry. So they're able to use environmental monitoring to ensure that all those regulations are being followed, and they're able to do that before any infractions are committed. The next is accident prevention. The manufacturing industry makes up about 7% of all workplace fatalities, so it's really important that they start putting more effort into making a safe environment, which they are able to do using sensors and environmental monitoring. Next, I'll have a demonstration on the dashboard.
This is the QuickSight dashboard. On the left-hand side, we have all the data that we can choose from to be displayed. All the data is coded from the sensors. You can also choose how the data is shown, which is right here, or you can have AWS choose for you. As you can see, here's the dashboard I created for our Capstone. This is the data we chose to go with due to the sensors we had access to. However, this is still very useful information to companies. For example, the air quality score right here, which is 0 to 3. 2.5 means calibration is completed. The index of air quality is shown. This number is between 101 and 150, which means it's unhealthy for certain groups, but not the general public. All these figures can be very helpful in manufacturing environments, but the data can be customized depending on what the company would like to observe.
So let's begin to wrap up. Now, I know what you're thinking. If there are all these benefits to smart manufacturing technologies and everything about it's so great, why the heck aren't more people doing it? Well, the answer is really one of comfort. what we see with manufacturing environments is a very traditional workforce that's kind of afraid of change. And smart manufacturing, the transition to smart manufacturing, represents a pretty big one. As we've also discussed, there are some security concerns regarding IoT devices. But as we've also discussed, through 5G, a lot of these security concerns can be alleviated. We're also talking about a knowledge barrier. People are concerned that implementing these technologies is going to be difficult, and training is going to be a very lengthy and taxing process. But I'm standing before you here today saying, if we can do it, so can they. Another thing that people are concerned about is cost. Now, we have an itemized list of our costs that we incurred or estimated over the course of this semester. And while it might seem a little bit prohibitive for us, for any mid to large size business seriously looking at improving their efficiency, the potential return on investment more than justifies any sort of investment on cost. So that concludes the technical part of our demonstration for you today. And I'd just like to direct your attention to the picture up on screen, because when a lot of people think about manufacturing, this is what they imagine. Dirty, uncomfortable, archaic technology, and dangerous. But with smart manufacturing, we can shift to a new paradigm: sleek, high-tech, safe, secure. And that is what smart manufacturing is all about, and that is how we believe we can bring manufacturing back to the United States.
Now, a little bit of a reflection from our group up here. Throughout the past few months during the semester, we logged collectively over 700 hours actively working on researching and implementing all the technologies that we discussed today. We had our ups and we had our downs during this 700 plus hours, but we were all very, very excited to see everything come together at the end and see everything working. We all learned a lot during this project. One of the main things I learned is that machine learning, while it sounds daunting and advanced at first, there are tools out there for absolute beginners all the way up to industry experts. So you can really get started with machine learning at any skill level that your workers have.
I'm personally just amazed how far AI has come. This is technology I foresaw being available in like 10 years from now. It's here today. It's going to look really exciting in 2 years. In 10 years, it's probably going to be terrifying. But it really is an exciting time. I am blown away at some of the new technologies that are out there.
From a technical standpoint, I obviously learned a lot in this project, and how when somebody takes the time to implement a technology, building it from the ground up with security in mind, 5G is an example of what can happen. But on a lighter note, learn to be a little bit more flexible, learn to change my role and adapt to the necessary requirements of the project.
My biggest takeaway from working on this project was what an incredible difference it can make having a great team behind you when you're trying to accomplish anything. When we were first looking at the statement of work for this Capstone project, we were understandably a little bit daunted. There was a lot to implement, but I'm incredibly proud of this group. We really pulled together and we did some great stuff, so thank you.
One thing I would definitely say I learned is, it's going to sound a little cliche, but don't be afraid to try new things. Before this project started, 5G, AI, machine learning, all of those just sounded like buzzwords that the bigwigs would finish and work on in 2 years, and then all of us guys, it would trickle down and we would start working on it. But because of this project, I was able to see that even if I don't know a lot, I can jump into the documentation and try and figure something out. And seeing what we were able to accomplish here really opened my eyes to see what these new technologies are capable of.
One of the things that I learned is that, is that 5G is not really just a number, that there are really truly improvements over the past cellular networks, and that this new generation of technology will bring in new technologies that use 5G that haven't been seen before.
This was my first time as project manager, so I got to learn more about the management side of IT, which I thought was really interesting, and I'll definitely take with me when I graduate. But we would really like to thank the CNIT Advisory Board for taking time off to watch our presentations, all of our CNIT professors throughout our years of study, especially Brandon and Holly for being advisors for this project. And our next presentation is Cisco Voice Log Automation, which is sponsored by Menards.